Assalamu alaikum. Dear students, today we will discuss mass spectrometry. It is our new chapter in organic spectroscopy. Before this, we have discussed UV visible spectroscopy, FTIR, and then nuclear magnetic resonance. So, it is our last chapter in which we will discuss mass spectrometry, its instrumentation, and how it works, and then after this video we will make another video on fragmentation pattern and then ionization techniques in mass spectrometry. So today we are going to discuss what is mass spectrometry, its introduction, its working, and the different conditions that we use during mass spectrometry. So mass spectrometer provides us molecular weight of compound. So it provides spectrum that is peaks according to mass to charge ratio of the compound. It only detects positively charged molecules or fragments. So it works with the positively charged or cations or positively charged atoms or molecules. Highest value of mass to charge ratio is the peak, which is called molecular ion peak, and the most abundant fragment which gives base peak. So the fragment which is more abundant and more stable is called base peak. So here we are going to show you the spectrum with mass to charge ratio. So mass to charge ratio decreases in this direction, and relative abundance or intensity of the molecular ion or fragment ion peak increases in y direction or in this direction, vertical direction. So here let we suppose that we have a molecular ion peak which is M plus, and here we have another peak which is M plus minus H. It means or minus CH3. It means that hydrogen or methyl group is removed from this, and if we look at the intensity of the molecular ion peak and this peak, we observed that this peak is more intense or more stable than this molecular ion peak. Therefore, this peak will be called as base peak, whereas this peak is the molecular ion peak. Sometimes we call a molecular ion peak as a base peak if its intensity is maximum than other fragments. So base peak is more stable, so therefore provides more intensity. It may be molecular ion peak like I have shown you. So therefore sometime molecular ion peak is also called as base peak. So what are the different steps involved in mass spectrometry? So first is the injection of our sample. Sample may be in gas form, liquid form, or solid form. So on the basis of the sample we use different type of ionization techniques. So these ionization techniques will be discussed later on. Then evaporation or vaporization of the sample. If it is not in gaseous form, then evaporation will occur in the vaporization chamber, and then ionization of these gaseous molecules will be occurred. And after ionization and fragmentation, here in this ionization chamber we get ionization and also fragmentation of the molecule, and then there are accelerating plates present which causes acceleration of the molecular ions, and these accelerated ions will be passed through the magnetic field where deflection of the ions will occur, and these charged bodies will be deflected in presence of magnetic field which is called deflection, and then these charged bodies or charged molecules or atoms will be detected at the detector, which is made up of different kind of materials that then they provide a signal in the form of electric current to the recorder where spectrum is produced. So these are the different steps which are used in mass spectrometry. So if we look at the ionization and fragmentation, here let's suppose we have the molecule in gaseous form, then it ionizes in this form and electron will be removed, and after this M plus, which is molecular ion peak, the fragmentation occurs and we get some neutral fragments and cationic fragments. So the fragmentation pattern is different in different ionization techniques. So we will discuss it in our later on videos, that how many kind of ionization techniques and fragmentation occurs. Now, what is the instrumentation of mass spectrometry? So if we look at the instrumentation or mass spectrometry meter schematic representation, here we have the point where sample is injected, and it is injected inside the vaporization chamber where there is some source which causes vaporization of our molecules, such as hot plate or some other methods which we can use. And then after this it will pass through the slit, and then it is entered in the ionization chamber where we have tungsten filament or some other filaments which produces beam of electrons, and these beam of electrons will causes ionization of these molecules and fragmentation of the molecules. So after ionization, these molecules will be accelerated by these plates which are present, which are negatively charged plates, and these positively charged cations will be accelerated, and these charged bodies will move from slit and it will enter into the deflection chamber, and all this process occur in a vacuum or very low pressure. Then these charged bodies, when passes through the magnetic field, they are deflected depending on their charge and mass. Depending on their mass and charge. So both these are important. That how many, what is the mass of that molecular ion, and what is the charge on that particular molecule. And after this deflection, they are detected by the detector, and these signals, those or detector causes a signal in the form of current, and they are recorded in the form of peaks in the spectrum. So these are the different chambers: vaporization chamber where evaporation occurs, and then ionization chamber, acceleration chamber, and then deflection, and then detector and recorder. So on what principle this whole mass spectrum works? So how we can calculate the mass? So if we look at here, there is a magnetic force which is the product of charge into velocity and the force of the magnetic field. So charge, velocity, and more force of the magnetic field, which is QVB. And here, when this molecule will move in a circular path, so it will produce a centripetal force which depends on mass of the molecule, velocity divided by radius of that curvature. So it is mv square by r. So if we look at here, this v and this velocity will be crossed, and it gives q b naught is equal to mv divided by r. By observing the radius of curvature, that is r, we get mass to charge ratio, mass mv divided by qb. So this is the equation from where, if we have a radius, we can calculate mass to charge ratio. So here, if we look at this equation, and this r, radius of curvature, will be directly proportional to the mass to charge ratio. It means if a body is more massive, it will have greater radius of curvature. So what is the radius of curvature? Here I am going to show you that here is the magnetic field and charged bodies are moving. One charged body is less massive than other has more mass, which is called m2. So this is m1 and this is our m2. So m2 is greater than m1, and here if we look at here, this m1 which has less mass, it will be deflected more, So due to its more deflection, its radius is going to reduce. So radius of curvature is less for M1, whereas in M2 it has greater mass and it is deflected less than the M1. So it will be deflected less and it will give us greater radius of curvature. And therefore, we get this mass 2 due to this radius R2. So after the detection of M1 and M2, the mass to charge ratio is calculated. And so the radius is directly proportional to the mass. So M2 is greater than M1 because R2 is greater than R1. If we look at the velocity, the bigger charge body will move slowly and will be detected late. So that's the reason that we have lower molecular weight present before the higher molecular weight. So lower molecular weight ions will be detected first and then higher molecular weight will be detected, which are present on right side of the spectrum. Now, what is the type of fragmentation? We will discuss types of fragmentation in detail in our next video. But before this, we should know how it occurs or what is the fragmentation pattern. So here we discuss briefly that what is the fragmentation pattern, and then we will discuss different type of fragments in our next lecture. So if we look at this example that we have a propane. So if electron beam attacks on this propane molecule, so we are going to look here. It is our first, let's suppose, then it is our second and third. So what different kinds are of fragment occur? So if electron beam attacks on non-bonding electron and it removes from this carbon, let's suppose we have this carbon and it removes this any non-bonding electron which may be inside the outer shell. Not it is not necessary that the electron will be from the valence shell. It may be from the internal shell also. That's why we have written here more electrons. So if it ejects this electron, which is non-bonding electron, we will get molecular ion peak. So electron is removed and we will get in this form, which is called molecular ion peak. And for this we will have a maximum mass of 44 gram. If we look at here, and electron beam attacks on this molecule and it removes an electron from the bonding electron, so it will eject the bonding electron and the proton will be removed from here, which will be in the form of free radical. So this electron for this proton, and it will get a free radical, and this fragment will be in this case in this type, that CH3 CH2 and CH2 positive, which will produce a carbocation. So in this way we will get a 43 gram peak, which is molecular ion peak minus one proton. So it will be like this. And in third case it may be that this electron beam attacks on the carbon-carbon bond and it ejects this electron from the carbon-carbon bond. It will break up into a fragment. And in this case, we will get CH3, CH2 plus this fragment and this methyl as a free radical, because one electron will be moved here and we will get free radical. And if this electron moves in this direction, if this electron moves, so we have two cases. If this electron moves in this direction, so we will get this free radical, this ethyl free radical, and for this we will get methyl as a peak or the positive ion, which will get us a 50 gram mass to charge ratio peak. And in this case, for the first case, if we have this cation, and we will get 29 gram peak, and the free radical will give us no peak, so it will be absent from the spectrum. So in this case we discussed that the fragmentation pattern may be different, and either it gives us a molecular ion peak or it will give us a molecular ion peak less than one proton, or it we will get different fragments. So it also depends on ionization techniques. We will discuss there are two types of ionization techniques, soft and hard techniques, and then we will discuss that fragmentation, how fragmentation will occur or not. So in some cases, in soft cases, most of the time fragmentation doesn't occur as much as in hard type of ionization. So, and we get the mass spectrum will be like this. Here we have 44, which is molecular ion peak, and then 43, 29, and 15. So the 15, the methyl peak will be very less in quantity or minutes. So today we have discussed that what is mass spectrometry and different type of instrument are different parts of the mass spectrometry and how it works, and then fragmentation pattern, that how a fragment will occur or how ionization will occur. But in our next lecture videos we will discuss different type of fragmentations like homolytic cleavage, heterolytic cleavage, and McLafferty rearrangement, and then we will discuss hard and soft ionization techniques. So thanks for watching my video.